good afternoon everyone. Myself Umang Kumar Singh and I am here to present my CEO activity, that is video making, on the topic of microprogram control unit. So what is microprogram control unit, you may ask. Microprogram control unit is an control unit inside the CPU. Uh, that produce some micro instruction that is stored in control unit to perform some micro operation. Why we need some micro instruction, micro operations, you may ask. For example, if you give a instruction to the computer like add, you may think that when we give the instruction add, the computer will perform the add in one single go, but that is not what happened. That is completely wrong. The computer need several micro steps to perform this one step. So what are the micro steps? For example, like when we give add, so the computer may need to take the opcode from the memory, and then it need to take specify one value to the accumulator and specify other value to any register, for example B, and then store both the value to the accumulator ALU, and then perform some instructions and then restore the value to the memory. For example, these are all the micro steps that had happened while we only tell the computer to add. So we cannot tell the computer each and every steps. That is too hectic. So that's why we have microprogram control unit. When we tell the computer to add, the microprogram control unit tell the computer which instructions to use, which registers to use, where to store the data, which hardware to use, and how we have to perform each instruction, so that we don't have to. And then there are two types of microprogram control unit. First of all is horizontal, second of is vertical. Horizontal is faster, required more memory, is complex design, and vertical is slower but takes less memory and has simpler design. Then there are some advantages. The advantages are it is easier to modify and update, flexible, and easier to debug. That's why most of the our latest computer use this technology, that is microprogram control unit. And it has some disadvantages too. For example, it takes more memory because it has don't memorize any instruction, it just takes instruction from the memory, and it is slower, but it is more flexible. That's why most of the computer today uses it. Thank you.
Hello everyone, my name is Anuj Vaisar. Today I am explaining vertical microprogramming space over speed. Vertical microprogramming takes the opposite approach, encoding multiple control signals into compact field groups. Rather than one-to-one bit mapping, control information is represented as encoded values that a decoder must interrupt before generating control signals. This impact design reduce memory consumption significantly. The first point is encoded field structure. Control signals grouped are represented as coded values, reducing word width to 16 bits or fewer. Second point, decoder logic required. Addition decoding steps convert fields values into actual control signals, introducing minor latency. Third point, memory efficiency. Compact representation dramatically reduce control memory requirements, ideal for resource construction system. Fourth point, space priority applications preferred when memory bandwidth or storage capacity is limited and speed is secondary. Field 1 ALU operation encode arithmetic operation type as 4-bit code. Field 2 source register specific input register address as a 3-bit code. Okay, thank you.
Hello everyone, my name is Bhakti Tadav and I am going to present the topic horizontal microprogramming, which is also a speed over speed. It represents a direct one-to-one mapping strategy. Each bit position might each bit position in micro instruction word corresponds to a single control signal. This eliminates the need for decoding logic, enabling immediate signals activation and superior execution. which is also which has also direct bit mapping, which means no decoding overhead means faster control signal generation, and also has wide words required, which is micro instruction formats typically span up to 40 and 100 bits to encode all signals. It has higher memory cost, which is wider words consume more control memory, increasing system footprints. It also has the priority design, which is best suited for performance critical applications where memory is abundant. Which I want to say is in horizontal microprogramming, each bit in a micro instruction represents one specific control signal. For example, if we want one bit may turn on the ALU, another bit may enable memory read, and another may read data into the register. Since every signal has its own bit on the decoding is required. That means the control signal are directly activated, making this method very fast. But this method, which is horizontal microprogramming, also has some disadvantage. And the disadvantage is that it needs very large memory space, because if there are 50 control signals and for that we need 50 bits in a micro instruction word. So this is the disadvantage, and this makes horizontal microprogramming wide and memory consuming, but also efficient in speed. It's often used in systems where performance is more important than saving memory. Also, suppose bit one. Suppose we have 3 bits in a micro horizontal microprogram in a programming, and first bit has signal ALU enables, which has function active arithmetic and logic unit, and the second is memory read, which functions the immediate memory fetch operations, and the third is register load, which writes to destination register. This is the overall concept of horizontal microprogramming. Thank you.